Hello students, this is the second video class where we will study about the types of support. The reactions whichever you are giving here, it depends on what is the type of support. What is the type of support? So let us go on to the topic: simple support, roller support and hinge support, fixed support, which are the types of support. So let us start with the first type of support, that is simple support. So simple support is, we can say that whenever the beam is simply supported onto a column or a wall. So it is simply supported. If this is the case, let us consider beam is AB and it is simply supported onto the column like this. So here I'll be applied with any types of load. Here let us consider again W1 and W2 like this, and it will be having simply support given by column. So at point A I'll be giving a vertical reaction RA, and here I'll be giving vertical reaction R. It is a representation, it is a simple support. See here, while studying the different types of support, you have to remember every four types are there. Every types of support has one representation, as well as it has number of reaction acting on it. So you have to remember what is its representation. Depending on the representation in the problem, you have to identify whether it is what type of support, and depending how you have concluded it as what type of support, you have to give the support reactions. So if you make any mistake in identifying what is the type of support, and for particular support there will be number of reaction and orientation of reaction to be given. So if you miss that one, the entire problem will be wrong. So that is why this is a simple support where only one reaction, that is vertically upward, is given. For example, you can say that simply a member or beam is placed. You can say that since it is supported here, it cannot be moved in y direction. For example, I'll take the axis, this is x, and since I'm drawing this one as 2D structure, this is y. So I can say that along y direction it cannot move. Why? Because it is supported by column. But along x direction it can move. If I apply a force like this here, it can move in the x direction. Or if I apply a force here, it can move in the x direction in this side. So it has all the translation ability in x direction, but it has no translation motion in y direction. Or else I can say that the translation motion in y direction is restricted. So in simple support, only one translation direction is restricted, another it is allowed, as well as rotation is also allowed. You can say that rotation also it is possible. I can rotate along x-axis, correct? If I apply a twisting moment like this, I can rotate the beam along x-axis. So one rotation is also possible. So here in simple support, only one restriction, two motion is possible. One restriction is, one translation restriction is there. Two under two, one translation, one rotational motion is allowed. So here the representation of simple support, I'll write here itself. Representation of simple support, this is a beam and one edge I'll take it as A. So at this edge, representation will be simply a reaction like this given, where naming will not be given. You have to name it. That is, here since it is applied on to point A, you will take it as RA. Or else it may be represented as, sometimes in some textbook it is only represented as a triangle. So this will be the representation. This I'll take it as again point A. This will be beam. anyways, this side also it will be supported by any other support reaction, but I am here, since I am showing the support, how to represent the support, I'm writing only the representation here at one side. So either it will be represented like vertically upward and or else triangle. So if it is given vertically upward, how to write it? I'll write here. So point A, how to write it? It is nothing but already given as upward reaction. I have to name it, that's it. Or else, if this is the representation, again it will be having one reaction along vertically y direction, so that it is not moving. Reaction is there so that it is not moving. So at point A, this is the free body diagram. So this will be the representation of simple support, and this will be the converted one. So you have to remember the representation, how simple support is represented, and then you have to convert it as a support reaction. So under simple support there will be only one vertical reaction that will be named under point of application. Okay, so this is simple support. So simple support are those which exerts reaction perpendicular to the plane of support. They resist or restrict translation of body in one direction. See here, in one direction translation is resistant, and but do not resist the rotation, as well as another direction translation as well as rotation is not resisted. So coming for the next support, that is roller support. Here roller support, the representation is nothing but, if this is a beam, representation is nothing but a circle and hatches like this. So this is a beam AB, or this point is A. So representation is circle or circle with hatches like this, or else it may be represented as a triangle like this, and a two circle and a hatch like this. This will be the roller. In AB, both side it is supported by a roller support. One representation is given like this, another representation is given like this. So though both these represent the same roller support itself, and the reaction is again the same. Here roller, say imagine a eraser present here, and it is placed just imagine this is a desk or a ground level. A eraser is placed and a scale is placed over the eraser. So you can see that you can't move the scale up and down along y direction because there is a resistance. So I have to give a reaction in this way, that is RE in both cases, RE, correct? And but if you have a eraser and placed a scale here, if I apply a force in this way or in this way, both the side it will move. So again this x direction translation is possible, and if I apply a twisting moment in this way along x direction, again the scale will rotate in along x direction, correct? So this along x direction translation and along x direction rotation both are possible, but there is no translation along y direction. So again this is 1 and 2. One translation is possible along y direction, not restricted along y direction, and 2 restriction is not allowed, that is one is translation along x direction, another one is rotation along x direction. So this is how the reactions are given. So while writing the free body diagram, you have to write vertically upward reaction is there, that is RA at point E. Here also vertically upward reaction is there at point E. So this is what the reaction you have to write, the same thing. leaving this representation, instead of writing the representation, you have to write the reaction. Again, you can see that they resist the translation of the body along in one direction and rotation is allowed. So one direction translation is restricted, and one direction translation as well as one direction rotation is allowed. Or the support may be placed in a vertical manner. So you have to write the representation in such a way that the support reaction should be always in 90° to the point of contact or plane of consideration. For example, the roller itself, if I'm saying that object is this B, and this point is, let us consider as point A, and your roller is given like this. So if you are writing the roller in this manner, so its reaction has to be written A, and its reaction has to be written in this way only. That is, for this plane of consideration, RA has to be written in 90° only. This is 90°, correct? Or to this point, it should be 90°. So this is RA, where if I draw a line, this should be 90°, and the other angle for the reaction has to be calculated while solving the problem. So it should be in that way. So I can say that for simple, I have to give one reaction. For roller, I have to give again, one reaction. But for pinned, see, representation of pinned, I'll tell you. If this is a point, it should be triangle. There is no roller, only direct hatch like this. Or else they may be having, this is a point, there is one pin or a circle, and there is a triangle. This is also called as pin joint. Or else, if there will be point, triangle, and hatch. So these all representation is nothing but hinge representation or pin representation. Just imagine your hinge in a door. A door is connected to the wall by a means of hinge, where you can rotate the door, but door is not movable in X direction as well as Y direction. So you cannot move the door in up direction or as well as in horizontal direction. You just imagine there is a door. You can't move the door in Y direction, up direction or down direction. You can't even move the door in X direction, that is towards the left or right of its point, but you can only rotate along the hinge. So that is what called as pin point. Or else I can say that if in the wall a chit is pointed by a pin or it is nailed by a pin, so I cannot move this chit in X direction like this or in Y direction like this, but I have all the rights to rotate the chit in this rotation along the pivot, that is point of that pin. Or else I can rotate in clockwise or either anti-clockwise. It has all the ability to rotate either clockwise or anti-clockwise, but it will not move in X direction as well as Y direction. It is the translation movement is not possible. So while writing the fluid body diagram, for example, for these, this is the same representation. For this case, I am writing only one representation here. So this is a point A where there is no possibility of moving in X direction, correct? So I'll be writing RA and Y because I have two reactions here. That is why RAY is one reaction, and it is there is no movement along X direction also. So I have to give a reaction in horizontal also, that is RAX. I'll take it as RAX. But there is a possibility of rotation here, so I can't say there is a resistance for rotation. So there will be two resistance for translation along x and y, which I have given like this. Vertically upward will be x, horizontally will be, sorry, vertically upward will be y, horizontal will be x. So wherein this Ex reaction, it may be written in this direction or in this direction, whatever direction. First, whatever the direction you are taking is the assumption. If you get the value in negatives, it will be saying that the assumption, direction of assumption of the force is not correct. It will be in a opposite direction. So anyway, that you will understand how to apply the forces or apply the arrow marks for the reaction and the while calculating the values in the problems. So anyways, you have to remember for pinned, there both the translation is not possible, only rotation is possible. So here you can see that for hinge support resist the translation in both direction, but rotation is possible. So I can say that here two reactions you have to give. Both these cases it is the same, representation is different, simple representation is different, roller representation is different, but reaction are both along vertically upwards. Okay, here pin vertically upwards reaction is also there, horizontal reaction is also there, and also representation different when compared to simple and roller. Then last one is coming for fixed, where all the three reactions or the translation, two translation as well as rotation is not possible. For example, representation is only one thing, that is one line with the hash. This is called as fixed. So this is called as fixed. It is fixed to a wall. If something is fixed, firmly fixed to a wall, it has no way to change its position. So if I say this is a x direction and this is y direction, it is not able to move in x direction, not able to move in y direction, as well as not able to rotate any x direction also. So if that is the case, you just hold the scale firmly in your hand and just apply the force. It is not movable in x direction, it is not movable in y direction, as well as if you rotate also, it is not movable. It is not movable. So that support is called as fixed support. So here, since it is not having any movement along x, y, as well as it is not having a rotation along x, so everywhere it is given with a reaction. That means the support is giving a reaction along y, along x, as well as a moment resistant is given. So this I'll take it as RAY, this I'll take it as RAX, and this moment I'll take it as resisting moment, I'll take it as MA, which may be clockwise or anti-clockwise. Again, whether it is clockwise or anti-clockwise, it depends on how you get the value or how the first assumption you have taken. You can take it as clockwise or anti-clockwise. See here in the figure, it is given with the beam AB, which is supported on either side by a fixed support. So you have one fixed support here. So since this is fixed support here, three reactions are there. So RAY, RAX, and a moment MA is given. Resisting moment MA is given, as well as this beam is supported, fixed supported at another end B also. So again there will be reaction along y, along x, as well as moment. Correct? So I'll name it in a different way because it is applied on to B. So RBY, RBX, and MB. I'll take it as MB related to the point B. So it is fixed support develop the internal moment known as restrained moment or resisting moment. It is also called as resisting moment. So fixed support are those which will resist both translation and rotation of the body. So these are the four types of supports. Here you can say three reactions are there. So you have to remember what are the names of the support: simple, roller, pinned or hinged, fixed. And what are the different representation of that one, how it is represented, and depending on the depending on the representation, you have to identify the type and then you have to give the reaction. So for simple and roller, representation is different but the reaction is the same. Pinned representation is again different manner when compared to other, but two reactions. Fixed, three reactions. This you have to remember. Then coming to the types of beam. So as you are dealing with the main structural component, that is beam, coming to that one, there are different types of beam. Then these types of beam I'll explain in the next class video.